This is Venkat from DataQuest. In this video, we will cover error handling in high performance architecture of Snowpipe streaming. What we are going to cover will have overview and the key error handling features that contain status endpoints, granular details, channel history view, the channel status endpoints, all the fields written by the status endpoint, error handling flow, step-by-step flow from client send to recovery action, SDK retry logic, automatic retries for transient HTTP errors, the fatal channel errors, the error codes requiring manual channel reopen, schema evaluation failures, channel invalidation due to schema user errors, authorization errors, UC 401, 403 errors, and the configuration fix guidance, HTTP status codes and exceptions, SF Snowflake exception codes, conditions and required actions, invalidation levels, channel versus client invalidation, what to reopen. So these are the contents that we will be covering in the next few slides. Let's see overview. The high performance edition of Snowpipe streaming provides a significantly enhanced error handling approach, offering detailed error information and a more robust informative ingestion experience compared to the classic architecture. It provides granular errors, a clear recovery path, historical visibility. Granular errors gives the detailed error messages with offset tokens, timestamps, and row counts that help pinpoint exactly where the ingestion failed. Clear recovery path gives the channel status codes that drive structured recovery. Retry mechanism, reopen or fix a config, no guesswork required. Historical visibility. Snowpipe streaming channel history view gives a full audit trail of errors and channel activity. Key error handling features. You have enhanced channel status endpoint, granular error details, improved client experience, channel history view. Enhanced channel status endpoint that extends the classic status code plus persisted offset token with a rich set of fields. It contains the last error message, error timestamps, row counts, processing latency, and more. Granular error details provides the last error message, last error timestamp, and last error offset upper bound to pinpoint exactly when and where in the data stream errors occurred. Improved client experience simplifies error reasoning with structured status codes that map directly to required actions, reducing custom error handling logic in client applications. The channel history view has a view available in Snowflake that provides historical record of channel activity, error trends, and offset positions for proactive monitoring. Channel status endpoint details. These fields that are given here returned by the high performance channel status endpoint in addition to the classic status code plus persisted offset token. The fields include the channel status code, the last committed offset token, created on timestamp, database name and the schema name, pipe name, channel name, rows inserted, rows parsed, rows error count, last error offset upper bound, last error message, last error timestamp, Snowflake average processing latency, milliseconds or microseconds. So these are the fields that are returned by channel status endpoint that gives a clear information of why the channel is failed and what is the accurate message, the error message that we can go over and try to fix the error or solve the problem. Error handling flow. First, client sends the data, the server processes it, buffers, parse, and validates, and commits to a table. Then you see an error. Error might occur at server-side processing stage. It records the error. Snowflake records offset upper bound, message, and timestamp. It reports the error with the channel status and the channel history view. Client will take the action whether it needs a retry, has to go through log, or gives an alert, or the data goes to the dead letter queue, or reopen the channel. This is an end-to-end flow of error handling in Snowflake, uh, Snowpipe streaming high performance architecture. SDK retry logic for transient errors. So what are the retry logic for some of the error codes? If you take a look at 500 or 5xx, anything starts with 5, those are typically errors at the server side. It's temporary server side issue. SDK retries automatically without data loss. If it is 4 to 9, that is too many requests. There is a rate limit exceeded error. SDK backs off and retries. Clients should also implement exponential backup. There is an auto retry for this. And there is 408 is a request timeout that is before the server responds. SDK retries the send of buffered channel data. There is an auto retry that is embedded part of HPA, high performance architecture. So there is no manual intervention needed when this kind of error codes are written. Fatal channel errors. There is a manual reopen required for the channels. A channel is invalid when a channel status code is not success. The SDK does not auto reopen. You must explicitly close and reopen the channel. Some of those error codes are error pipe does not exist, error pipe does not exist or not authorized. Target table is missing or inaccessible. Row sequence state is invalid. Channel sequence state is invalid. General error like channel is unusable. A gap detected in row sequence. So these are some of the error codes typically written which are fatal channel errors. The action you would take is typically to fix the pipe or open a channel and fix the table issue, then reopen the channel. Or more importantly, for many of the cases, if channel is in invalid state or if there is a gap detected, reopen of a channel is required. Schema evaluation failures and channel invalidation. Exception to on error equals to continue. Even when this option is set, the channel is invalidated if schema evaluation fails due to user errors. It triggers channel invalidation. Submitting the data with invalid column names that cannot be mapped to a target table schema. Adding more columns than allowed by the configured column limit within a single batch. Adding columns across multiple batches has no column count limit, just a note. How do we verify and recover? You have APIs called get channel status to verify invalidation status and reason for the failure. Inspect the channel status code returned in the response. Fix the offending data, typically column names or schema mismatches, before retry. Close and reopen the channel to resume ingestion after correcting the issue. So this is more like reopening the channels because of schema evaluation or channel invalidation failures. Authorization errors. Fix config, don't reopen. So you would see authorization issues when you initiate a client request that goes to server and the request is rejected. A new channel will immediately hit the same problem until the underlying config is fixed. So it is more important to fix the configs before reopening the channel because it would be the same problem for a new channel itself also. So 401 is generally unauthorized error code. 403 is forbidden when authenticated, but the client lacks permission to access the target pipe or table. Correct recovery procedure is to stop the ingestion and fix the root cause, typically fixing the permissions or authentication credentials. Reopen the client. After authorization issue is resolved, reopen the client to resume normal ingestion. SDK exceptions and HTTP status codes. The Java SDK methods such as insert rows, get latest committed offset token, get channel status may throw Snowflake exception. Inspect those HTTP status codes to determine recovery action. For example, 409 is channel invalidated. Close the channel, reopen it, and resume from the last committed offset. If there is 429, which is more related to throttling, client sending too fast, implement exponential backup and retry strategy. 500 or 503 service error, which means transient network or server side issue, retriable after a short delay would fix the problems. 401 is unauthorized authentication fail. Verify the credentials, JWT config or role permissions. Understanding invalidation levels. It is critical to distinguish between a channel invalidation and a client invalidation. They require very different recovery steps. On the left side, you would see channel only. On the right side, it is more specific to client. Invalid channel exception is thrown with typically HTTP 409. Only specific channel is affected. Close that invalid channel, open that channel to create a new instance and resume ingestion from the last committed offset token. On the client exception calls, the entire Snowflake streaming ingest client is compromised. Close the existing client completely. Initialize a new client using the factory. Reopen all associated channels on the new client. So there are different ways you tackle errors in Snowflake. More importantly, in this slide, we talk about channel error handling, and client-side error handling. The key takeaways when it comes to error handling of Snowpipe streaming of high performance architecture, there is rich status endpoints you could see based on the error offsets, the fields that HPA architecture provides. Auto retry mechanism for transient errors, especially at server side. The fatal error codes like error channel must be reopened, and 5 others require explicit channel close and reopen to recover. Auth errors equals to fix the config means Even if you reopen a new channel, it would give the same error. So it is better to fix before we reopen a new channel. Schema errors invalidate. Most importantly, these will come because of the limitations of the schema evaluation are the columns that are affected with schema changes. So they need to be fixed before reopening the channels. Channel versus client scope is very important to understand. Channels just need to be closed. The error channels only need to be closed and reopened. The client scope, you might have to restart the client factory. So these are the takeaways from error handling for an HPA from Snowpipe streaming.